I go.
Yes, good afternoon, class. Welcome to today's lesson. Today, I want us to do a topical revision on the common areas that are tested in chemistry, especially the structured areas. So I want to take this opportunity to welcome each and every one of the viewers that is online right away. I know there are students who are there, there are teachers who are following, and also other members of the public. So welcome to today's presentation. Your presenter is Mr. Shadrach Kirwa, uh, a teacher by profession, teaching chemistry, biology, major chemistry. So I want to ask to feel free, let us interact in this forum, and we go through some of these questions that may help us in a way or another. So having said that, today I've taken this opportunity, at least we go through a few areas that may be of problematic to you, and then we share and we also help each other develop. So welcome, dear students, to this lesson. Okay, so I came up with this because of the current situation that we are in now. We have students at home, they have overstayed at home, at least to remind ourselves so that we do not forget some of these things that we ought to know. So welcome, feel free. I want to appreciate most of the friends that promise that they will be live. If you are there and we had interacted in the wall and you promise to be there, so feel free and welcome. Salamu ziwafikie nyinyi wote. There are a number of people who told me to recognize them. I'll recognize you at the end of this discussion. So welcome, let's go straight to the point, what brought us here. So first of all, so this is topical chemistry revision on a few selected topics. Today we'll do common topics on the periodic table. We have common topics on questions on the acids, bases, and salts, and thereafter we look at organic chemistry, at least to where this will enable us to go. So let us go to start with the periodic table. This is number one, periodic table. Now, so we have, normally you are provided with a periodic table, then you are asked questions. So I want us to go to the first question on the periodic table there. Now, the first question says, the grid below is part of the periodic table. Use it to answer the questions that follow. Of course, as always, letters do not represent the actual symbols of the elements. Okay, so looking at that periodic table, we have D. We have, normally when we have a periodic table, all of us are aware, at least in from a chemistry class, that this one is group 1, and then we have group 2, we have group 3, we have group 1, 2, 3, 4, 5, 6, 7, and group 8. In between here, we have the transitional metals or the transitional elements. Now, so D, we have D at this point. So this is D is in group 1. We have E in group 3. Group 4, we have A and F. Group 5, 6, we have B. Group 7, we have C, G, and H, and then group 8. So if you look at this, members of group 1 are called alkaline earth metals. Group 2 are called group 1 is alkali metals, group 2 is alkaline earth metals, and then group 7 are the halogens, and finally group 8 we have the noble gases, or sometimes we call them rare gases. Okay, so let's after you've studied that, now, so as when we go down, basically, when we go down, we normally say down the group. So down group 1, down group 2, down group 3, like that, up to down group 8. across from left to right, this is period 1, period 2, period 3, and period 4. So when we move from left to right, then we are going across the period. So from, for example, A to B, that is across period 2. From D to E to F and G, that is across period 3, and so on. Okay, so having said that, let us go to the first question there. So the first question says, which is the most reactive non-metallic elements shown in the periodic table? Now, normally, group 1, group 2, and group 3 are metals. And then from this other side, the rest are non-metals. So D is a metal, E is a metal, and the A, F, B, C, G, and H are non-metals. Okay, so let us group it this way. We have metals, and then we have non-metals. So from the periodic table, D is a metal in group 1, and then we have E is also a metal. Now the non-metals, basically we have A, F, we have B, we have C, G, and H. So those ones are non-metals. Now looking at the first question there, the first question says, which is the most reactive non-metallic element? Now we have most reactive in terms of metals and most reactive in terms of non-metals. When you talk of most reactive, the most reactive metal is always potassium, which is in group 1, followed by sodium, which is just above it. When you go to most reactive nonmetals, we are saying potassium is the most reactive because when you look at the electron configuration of potassium is 2, 8, 8, 1. So because it has 4 energy levels, it is the most electropositive, so it is the highest reactive, the most reactive metal. For nonmetals, reactivity, you go to group 7. So group 7 are the halogens. So the most electronegative halogen is fluorine. Now if the question says which is the most reactive non-metallic element. So I've said when you come here, these are the most reactive metals. Now the most reactive non-metallic element has to be C. So because electronegativity decreases as you go down the group. So C is the most electronegative non-metal. So the answer for the first one is C. Next question. The next question says, name the bond type in the compound formed in B1. Write the formula of the compound formed when element A reacts with B. So when A here reacts with B. So when you want to write the formula, you need to know the group. So looking at this, A is in 1, 2, 3, 4, is in group 4. So A is in group 4, B is in group 6. Now A is group 4, B is group 6. Now when you say group 4, it means the valency of A is 4. The valency of B is 6. Is 2. The valency is the number of electrons that an element either gains or loses. So A valency is 4. B, it gains 2, so the valency is 2. Therefore, for you to write the formula, then you say this one, you interchange the valencies. This comes here, this goes there. So therefore, you have A, 2, B, 4. Now when you cancel, there is the common factor between them is 2, so 2, 1, 2, 2. So that makes you have A, B, 2. So that is the formula of the compound that is formed between A and B. Next question says, name the type of bond name the bond type in the compound formed in D above. So that is, we know, we have said up to here are metals. Now these ones are non-metals. When a metal forms bonds with a non-metal, then that is ionic. When a non-metal bonds with another non-metal, then that one is covalent. So therefore, the bond is covalent bond. Next question is, what is the name given to the group of elements where C, G, and H belong? So those ones are halogens. Those ones are halogens. Those are halogens. That is the name of the group. You don't call them group 7. They are in group 7, but the name, the family name given to them is that they are halogens. Very good. Write an equation for the reaction that occurs when C in gaseous form is passed through a solution containing ions of element H. Write an equation for the reaction that occurs when C in gaseous form is passed through a solution containing the ions of element H. Okay, so C, both of them are in group 7, so that has to be a displacement reaction. So C in gaseous form. So C in gaseous form. Now, because they are group 7, then this one is 2. Sorry. You have C2 gas reacting with the ions of H. This one is aqueous. Then that one forms. Okay, let me turn over. So we have C gas reacting with the H ions in aqueous state to form. So this one displaces H from its ions. So you have C aqueous and H gas. When you balance, so this is C2, so this one will be 2. H is 2, so this one is 2 again. So that is the equation for the reaction. D of F and G are 1410 degrees Celsius and negative 101 degrees Celsius respectively. In terms of structure and bonding, explain why there is a large difference in the melting points of F and G. So we have elements F and G. So F here contains 1410. G here contains negative 101. Now, when you have F is 1410 degrees Celsius, and G, so these are melting points. G is negative 101 degrees Celsius. Basically, because G is group 4, F is in group 4, G is in group 7, noble gases. So the reason is because this one is bonded by covalent bonds. So it forms a giant atomic structure. Whereas G is in group 7, it is simple molecular structure. Simple molecular structures contain weak van der Waals forces of attraction. So it has weak van der Waals. So G is of simple molecular structure containing weak van der Waals force of attraction, which are easy to break. Whereas F is made up of giant atomic structure, whose structure is very strong, and it requires a high melting point in order to break the forces of attraction. So normally we always say the stronger the forces of attraction, the higher the melting and boiling point, and vice versa. Next, D forms two oxides. Write the formula of each of the two oxides. So D is in group 1. This is period 1, period 2, period 3. So possibly D is sodium. Now the sodium forms two oxide, that is sodium oxide and sodium peroxide. So the formulas are sodium oxide is D2O. This is sodium oxide. Sodium peroxide is D2O2. So that is, this is sodium peroxide. Now we don't say sodium because it is D. So this is a peroxide and this one is an oxide. So that is it. Next question is J is an element that belongs to third period of the periodic table and is a member of the alkaline earth metals. So show the position of J in the grid. So J is in period 3. So period, this period 1, period 2, period 3. So D is in period 3 and then it is a member of alkaline earth. So we said this is alkali metals. These ones are alkaline earth metals group 2. So therefore, that means if it is in period 3 and is a member of group 2, so this group 1, this is group 2. So is in period 3. So the period is 1, 2, and 3. So this one is here. So that means J is here. So that is the position of J in the periodic table. So that is for question number 1. Question number 2. The grid below represent part of the periodic table. Study it and answer the questions that follow. The letters given are not the actual symbols of elements. So you've been given another periodic table there. As we've already said, this is group 1, this is group 2, this group 3, this group 4, group 5, group 6, group 7, and group 8. Also this period 1, period 2, period 3, period 4, period 5, etc. So that is, you have F in group 1, B and G group 2, C group 3, D group 5, group 6A, and group 7, E and H. A says, explain how you'd expect the following to compare. So we are comparing the boiling point and the melting point of E and H. E and H, both of them are in group 7. Basically, for group 7 elements, as you go down the group, there is increase in molecular size or molecular mass. Now, as the molecular size increases, there is increase in strength of intermolecular forces of attraction. So as you go down group 7, the intermolecular forces of attraction increases. So because intermolecular forces of attraction increases, then it means melting and boiling points increases down the group. So for group 7 now, melting and boiling points increase down the group. And we have said that is due to increase in intermolecular forces of attraction. This is because of increase in intermolecular forces of attraction. Actually, that is the reason why as you go down group 7, the first one is a gas. Fluorine is a gas. Chlorine is also a gas. And then bromine is liquid. And finally, iodine is solid. So you see there is increase in intermolecular forces of attraction from gas to liquid and finally to solids. So that is for that question. Next is compare the atomic radii of F and G. Compare atomic radii of F and G. So F is in group 1, G is in group 2. You realize when we said what we said here is that as you go across the period, there is increase, there is decrease. Generally, there is decrease in size. So this from F to G is across the period. Now, across the period, there is increase in nuclear charge. So we are expecting that F has a smaller atomic radius compared, G has a smaller atomic radius compared to F. So F has a larger atomic radius. Now the reason for that is because there is increase in nuclear charge across the period. So because the nuclear charge increases across the period, therefore you have the size decreasing. So you say F has a larger atomic radius than, of course, than G. Or the other way is saying G has a smaller atomic radius. Both of them are the same, one and the same thing. Next question is 2.6 gram of B react completely when heated with 2.42 decimeter cube of gas STP. You have been told 1 mole of gas at STP occupies 22.4 decimeter cube. Now that question is incomplete. It is supposed to say calculate the RAM of B. Calculate the RAM of B. So we have B reacting with gas E. So B reacts with E. So this one is group 2, this is group 7. Now, so basically, this is what happens. B is a solid, reacts with gas E, which we said is 2. This forms BE2 solid. So here, the equation is balanced. So we have 2.6 grams of B and 2.46 decimeter cube of gas E. All right. So 1 mole of a gas we have told occupies 24. So normally STP is standard temperature and pressure, and the volume is 22.4 decimeter cube. Okay. So because you have this volume, you have this value here, which is 2.46, and you have the volume at STP, which is given at 22.4 decimeter cube. So that means you can calculate the volume, you can calculate the number of moles here. So you take 2, so moles, number of moles of E is given by 2.46 divided by the volume at, that is 22.4. Okay, so the value you get there just a minute. Yeah, so that is 2.46 divided by 22.4. So that is I want to believe you will get the same thing with B, 118 2 moles. So that's the number of moles of this. Now, so the number of moles here is 0.1182. All right. So, because the mole ratio B to E2, the mole ratio is 1 to 1. So, mole ratio, the reacting mole ratio is 1 to 1. Therefore, that means the moles of B is the same. So 0.1182 moles. Okay. Now, so you have the number of moles here as 0.1182 moles. You remember the formula that we normally use this triangle to give a relationship between mass, molar mass, and the number of moles. So this formula says when you have mass and you have the number of moles, then you can calculate molar mass, which means molar mass in this case, molar mass is RAM, is RMM. So molar mass is given by mass divided by moles. Looking at this, our mass is 2.6 grams. Our moles is 0.1182. So that means for you to get molar mass, you take mass, which is 2.6, divided by number of moles, which is 0.1182. Now, when you do this, you will get 24 point something, 24.02. That is molar mass. Molar mass does not have units. So the RAM of B is 24.02. Probably when you look at your periodic table, the periodic table that you are provided there, when you look at the periodic table, then B is likely to be magnesium because magnesium is in period 2 group, period 3 group 2. So B is likely to be magnesium, and we know that always magnesium, RM of magnesium is 24. So we are most likely to be right. So that one is a correct thing to do. The next question says, write a balanced equation for the reaction between B and E. So I think we have already written that. The mole ratio, reacting mole ratio is 1 to 1. So it's the same. Next is determine the relative atomic mass of B. Already we have done that. So we calculated before we answered the questions. So determine the relative molecular mass of B. That is what we just did. Next, what type of structure will the chloride of C have? Back to this table. So we want to know the chloride of C. You realize that C is in group 3, period 3. That happens to be aluminium. Now, if you remember aluminium from structure and bonding from 2-1, across the period, we have aluminium chloride. Now, aluminium chloride is written like this, but it does not exist as aluminium chloride. It exists as this Cl6. This one is called a dimer. So when it is dissolved in water, for example, it dimerizes. Now we expect that because this one is a metal and chlorine is a non-metal, we are expecting that it forms an ionic compound. But now, instead of being ionic, it dimerizes. So when it dimerizes, it ceases to be ionic. That means it forms covalent bond. Now the structure, so the bond is covalent. And then the structure is simple molecular. So this aluminium chloride forms a simple molecular structure because it dimerizes. It does not behave like magnesium chloride, which is purely an ionic compound. So that one is simple molecular structure. The bond is covalent bond. So that is it. C2 says select an element that can form an ion with a charge of -3. So charge of -3 from the table, you look at, so the easiest way to do it is to start from here. So this is group 8, group 7, and this is group 5, or group 1, 2, 3, 4, 5. 6. Oh, okay. So this one is group 6. Now, group, sorry, this group 1, group 2, group 3, group 4, group 5. So if it is D is in group 5, that means when we say group simply means the outermost energy level contains 5 electrons. That's why it is called group 5. So because it is in group 5, for this element to be stable, the outermost energy level contains 5 electrons. Now, for this element to be stable, then it requires to gain 3. It requires to gain 3. Okay. So because it requires to gain 3 electrons, then it has it gains 3. That means it will have a charge of -3. So that element is D. So D is what forms. Select an all element that can form. It should be select an element that can form an ion with a charge of -3. So that is D. Next is give 2 uses of element E. Give 2 uses of element E. So E is a group 7 element. Normally in group 7 we start with fluorine and then chlorine. So E is chlorine. So 2 uses of chlorine. Chlorine is used in treatment of water. Chlorine is also used in manufacture of polymers. Is used in polymerization, including others. Basically, those are 2. Next is question 3. So we are done with 2. Question 3 says the table below gives some elements of the periodic table and their atomic masses, atomic numbers, and melting points. As usual, letters are not the actual symbols of the elements. So you have element B, C, D, E, F all the way up to K. Atomic number. So B is atomic number 7, C atomic number 8, number 9, etc. Then we have atomic masses, and finally we have the melting point. What I want us to do is to group them. Let us, because we are studying, the question says you use the table to answer the question. So let us first of all understand the table. So for us to understand the table, I want us to use the atomic number. So B is atomic number 7. So this atomic number, if it is atomic number 7, then it means the electron configuration of B is 2, 5. And then C, electron configuration is 2, 6 because it is 8. Maybe I should write going down. So B is 2, 5. C is 2, 8. D is number 19. So this atomic number 7, atomic number 8. Number 8 is 2, 6, 2, 6. And then number 19 is 2, 8, 8, 1. E is 15. So this is 2, 8, 5. And then we have F is atomic number 2, so that one is just 2. Oh, there is no dot here, sorry. And then we have G. G is atomic number 9. Atomic number 9. So 2, 7. Then you have H. H is atomic number 6. So this one is 2, 4. I is 16. That's 2, 8, 6. J is number 12. That is 2, 8, 2. And then K. K is 11. That is 2, 8, 1. Wow, very long. Okay. Now looking at this, simply when you write electron configuration, it enables you to know the group and the period. For example, you will know this one is in group 5 period 2, group 6 period 2, group 1 period 4, group 5 period 3, group 2 period 1, group 7 period 2, group 4 period 2, group 6 period 3, group 2 period 3, group 1 period 3. So you can easily group the ones that are in the same group. For example, simply when you look at this, you realize that B and E belong to the same group. So B and E belong to group 5, both of them, because there are 5 electrons. C, 6. We also have I, group 6. We have group 1. We have group 1. Okay. We have group 2. We have group 2 here. So we only have one group 7. So that is how we study the table. Now when you also look at the groups, you will realize that we said group 1, group 2, and group 3 are metals. So the metals that you have here, group 1, you have D, you also have K. Then the other one is group 2J. We also have another group 2, that is F. These are metals. The rest are non-metals. So metals are D, K, J, and F. The others are non-metals. So that is how we group them. And now let's look at the table. Back to our table there. Atomic mass. Atomic mass. Then you have melting points. You see that you find that the melting points, others are negative, others are positive. So the first question says, select 2 elements with oxidation states of -3. Now, oxidation states of -3 mean they gain 3 electrons to be stable. So therefore, if they gain 3, that means the outermost energy level should have 5 electrons in order to gain 3. So basically, that is group 5 elements. So it is B and E. So B and E. These ones form ions with charge of -3. So that is B and E. Next says, which element represents the most powerful reducing agent? The most powerful reducing agent. Reducing agents, normally the basic rule is group 1 are the strongest reducing agent, starting from the lowest. So normally, basically what you should have at the back of your mind is that reducing agency goes hand in hand with the reactivity series, whose reactivity series, which potassium is the most reactive, followed by sodium, followed by calcium, followed by magnesium, aluminium, etc. Now, so that means if potassium is the most reducing, the most reactive element, that means it is the strongest reducing agent. So always when you are looking at the reducing agency, then you begin with, if in this group you have a group 1, and then you compare them. So reducing agencies, group 1 are the strongest, followed by group 2, followed by group 3. By the time you are at group 7, you are talking about oxidizing. So that means in this table, look at the table. In our table, we have group 1. We have group 1, which is this, and we have group 1, which is this. So we have to choose between the two. One of them is the strongest reducing agent, followed by the other. So basically, when you look at D, it has 4 energy levels. K has 3 energy levels. Basically, this is potassium. Actually, basically, this one is sodium. So looking at your table, you simply pick D. So D is the strongest reducing agent. Potassium is actually the strongest reducing agent in the periodic table. For our case, because we do the first 20 elements, fluorine on the other side is the strongest reducing agent. That's by the way. Next question is, how does the atomic radius of D compare with that of K? D compare with K, the same thing, that the same area where we were. So you are comparing D and K atomic radius. So you look at this has 1, 2, 3, 4. This has 4 occupied energy levels. D. K has 3. So because this one has 4, this one has 3, normally 4 is greater than 3. So D will have the highest atomic radius because it has 4 energy levels. So that is when the question says compare, and then you explain. Compare is either greater or smaller. So you say D has a smaller atomic radius than K. No, D has a larger atomic radius compared to K, or K has a smaller atomic radius compared to D. So that is the case there. The reason we have said is because D has more energy levels compared to K. Next, how do you compare electrical conductivity of D and J? Now look at D and J. D is, we can even use the table. Okay, it's okay. Let's use this one. So you are comparing electrical conductivity of D and J. The most important thing to note, first of all, is that D is a metal, J is a metal. Now, basically, electrical conductivity increases with increase in the number of delocalized electrons. The more the number of delocalized electrons, the higher the electrical conductivity. The lower the number of delocalized electrons, the smaller the electrical conductivity. Therefore, that is to say, D has 1 delocalized electron. J has 2 delocalized electrons. So basically, J is a better electrical conductor than D, or J conducts electricity more than D. The reason is because D has 1 delocalized electrons, 1 delocalized electron. J has 2 delocalized electrons. So electrical conductivity increases from group 1 to group 2 to even group 3. So by extension, that is why aluminium is always the best electrical conductor, because it has 3 electrons, followed by magnesium, which has 2, followed by sodium or potassium. So sodium has 1. So you see 1, 2, 3. So from group 1 to group 2 to group 3, electrical conductivity increases in that direction. So that is it. Select 2. The next question is, select 2 elements which, when reacted, form a compound that conducts electricity both in molten and aqueous state. Select 2 elements which, when reacted, form a compound that conducts electricity both in molten and aqueous state. Okay, so here, from our list of elements here, from B to K, you select 2 which, when they are combined, forms a compound which conducts electricity both in molten and aqueous state. What is the difference between the two? Now, molten is a solid substance which melts. When you hit a salt, it melts. That form is called a molten state. Aqueous state is when you dissolve in water. When water is added, for example, to a salt, then it dissolves. The solution formed is said to be in aqueous state. Now, for electrical conductivity, for us, because we have done structure in body, now, for any substance to conduct electricity, there are two requirements for electrical conductivity. Let me use here because we are still coming back to this. So, for a substance to conduct electricity, it must have either delocalized electrons or mobile ions for any electrical conductivity to take place. Now, delocalized electrons applies for all metals except graphite. So we say all metals and graphite conduct electricity because they have delocalized electrons. Now, for mobile ions applies only for ionic compounds. Those compounds which, when they react, they form a compound which is an ion. So, for all ionic compounds, they conduct electricity because they have mobile ions. And that is either in molten state or in aqueous state. So, for example, sodium chloride, potassium chloride, sodium oxide, sodium sulfate, but any ionic compound where when we talk of ionic, we talk of when we talk of ionic compounds, this is where a metal reacts with a non-metal. Now, for example, in our groupings here that we have done, we have said the metals that we have here, we have D. D is a metal. Another metal is, okay, leave alone F. Okay, this one is in group 7. Sorry, this is in group 7. We forgot to mention that before. Sorry for that mistake. So F is group 7. Now, so D is a metal. Another metal here we can see is J. The other metal is F. So we have how many metals? We have 3. We had already written them here. We have D, D, not F. Oh, F is not there. Sorry, F is not a metal. F is a metal because this one is a duplet. We call it the state is duplet. Now, so the metals are D, group 1, M, group 2, and K, group 1. So metals are D, J, K. The non-metals, I want us to leave group 4 alone. Now, the non-metals we have is this non-metal. These are non-metal. E is also a non-metal. F is also a non-metal. G is a non-metal. I is a non-metal. Those. So we have metals as D, K, J. Now, so you pick. So we have said D, K, J. Those ones. Yeah? J? Yes, J. D, K, J. Non-metals. Let me write on this other side. These are metals. Non-metals here we have B. We have C. We have E, F. Then we have G and H. Now, basically we have said B is group 5. So B is group 5. C is group 6. Sorry, group 6. E is group 5. F, F is 2, that's a stable one, is group 8, it is a noble gas. G is 2, 7, this one is group 7. And then H is group 4. Now, when you are picking two that when they react, they form ionic. So we want to find an ionic compound. So an ionic compound is a compound formed between any of these metals, and so we leave group 5. 6 is okay. In that, group 8 is non-reactive, is stable. Group 7, group 4 also. So when our question says select any two elements which when reacted form a compound that dissolves in water. Oh, sorry. Previous question. Select two elements which when reacted form a compound that conducts electricity both in molten and aqueous state. So we are looking at, from this we have said for a substance to conduct electricity in molten or aqueous state, it has to be an ionic compound. So we want to look at ionic compounds here. So it can either be D and C, K and C, J and C. So whichever one you choose to, you write one of them. Can be D, C, K, C, J, C, or also this one. D, D, G, K, G, J, G. So like that. I should have used a different pen. So it can be D, C, K and G, K and C, J and C, D and G, K and G, or J and G. Any one of them. So any one of them there is a correct answer. Okay, next. State any two elements which, when reacted, form a compound that dissolves in water to form an acidic solution. Okay, so for you to form an acidic solution, that means the reacting substances are nonmetals, because a metal with a metal is ionic substance, and ionic substances form base when they react, when they are dissolved in water. So for you to get ionic substance, and I mean a substance which dissolves in water to form an acidic solution, then that one has to be nonmetals. So it is either, so this group 4, so it is either between H and, so you look for group 4, because we have group 4. An example of group 4, by the way, is carbon. Okay, an example in group 6. So let's look at example, for it to be simple, let's look, say, for example, carbon. Okay, group 7, for example, chlorine. Group 8, for example, argon. Group 5, for example, phosphorus or sulfur. Group 6, for example, oxygen. Group 5, we have said an example is phosphorus. So you look at any of these which can form a compound. For example, you cannot say you have carbon chloride. Now, so it is either carbon and oxygen to form carbon 4 oxide or carbon 2 oxide. And then we also have phosphorus and oxygen to form phosphorus 5 oxide or phosphorus 3 oxide. So in that case, we are saying it is either H and group, this one, group 6, C, or P and C. So this form a compound which when dissolved in water forms an acidic. By the way, phosphorus and oxygen is phosphorus pentoxide. When it reacts with water, it forms phosphoric acid. Carbon and oxygen form weak carbonic acid. So it is either H and C or P and C. So that is, those are the substances when they react, they form a compound which dissolves in water to form an acidic solution. Number E. E In which period and group do elements D and G belong? Element D and G. To which group and period? So we have written electron configuration of D. So without wasting time, D is in period 4. So you can, this other side. So D is period 1, 2, 3, 4. Period 4, group 1. And then G is in period 2, group 7. So period is the number of energy levels. Group is the number of electrons in the outermost energy level. Now, the next question says, explain why the melting point of K is higher than that of D. So K is 98. K is 98. And D, yes, K is 98. D is 63.7. So K has a melting point of 98. This is 63.7. What we know basically is this is 2881. This is 281. So these are group 1 elements. This one has a larger atomic radius. This one has a smaller atomic radius. So D has a smaller melting point because it has a larger atomic radius. What you need to know is the larger the atomic radius, the weaker the forces of attraction. The larger the atomic radius, the weaker the forces of attraction. When the forces of attraction are weak, then the melting and boiling points are low. This one, the smaller the atomic radius, the higher the forces, the stronger the forces of attraction. The smaller the atomic radius, the higher the stronger the forces of attraction. When the forces of attraction are stronger, the melting and boiling points are high. Therefore, K has a larger melting and boiling point than D because D has a large atomic radius. So that is the difference. Finally, how does the atomic radius of K and I compare? How does the atomic radius of K and I compare? So let's look at K and I. Let's look at K and I. K is in period 3, group 1. I is in period 3, group 6. So the thing is, both of them are in group 3. The difference is, when you begin from your left side of the periodic table, we begin with group 1 and then group 2, group 3, group 4, group 5, group 6, group 7, like that, up to group 8. Now, as you go this direction, we said from left to right, that is across the period. So, across the period. So, if K, for example, K is group 1, K is here. I is group 6, I is here. So, from K to I, that is across the period. Earlier on, we said across the period. Okay, now take this one off. That was the last question for that part. Now, K and I, we are moving across the period. Now, we say across the period, there is increase in nuclear charge. All time, you always say atomic radius increases across the period. Atomic radius will always increase across the period owing to the fact that the nuclear charge increases across the period. So if we say atomic radius increases across the period, we are saying K has a smaller, yes, atomic radius I will have a smaller atomic radius compared to K. So we say decrease, not increase. Sorry. So this one is decrease across the period. So atomic radius decreases across the period. This one will have a larger atomic radius followed by so larger, and then to I is small. So I has a smaller atomic radius compared to K. The reason for that we have said is because of the increase in nuclear charge across the period. So it is the same as the one we were comparing here. Now look at this. We were comparing the atomic radius of F and G. We said across the period decrease. So G has a smaller compared to F. Why? Because of increase in nuclear charge across the period. So that's all for that particular question. So we are done with periodic table. Those are just a few questions. Next time we will we'll talk about the periodic table entirely. So that is for the periodic table. Now we go to another topic, which is acids, bases, and salts. Acids, bases, and salts. Acid, bases, and salts is a first topic in Form 4. Periodic table combines questions from the first three topics of Form 2 and also Form 4, the reducing and the oxidizing action. That is electrochemistry. So this one is Form 4 work. The first topic in Form 4 work is called acid, bases, and salts. And you know that in Form 1 you did acid, bases, and indicators, and then in Form 2 you did salts. So actually this is a combination of the two topics. So let's look at the first question there. Study the reaction below and answer the questions that follow. So you have, so the reaction is ammonia gas reacts with water to form ammonium ion and hydroxide ions. Okay, so the first, the equation is ammonia gas reacts with water to form ammonium ions and hydroxide ions. Now, from this equation, we can answer the questions that follow. Define the term acid. So define the term acid. All time we say an acid is a proton donor. Form 1 say an acid is a substance which reacts with a base to form a salt and water. But for Form 4, we say an acid is a proton donor. Now, have in mind that when we say a proton, we are talking of a hydrogen ion. So when we say proton donor, then we mean an acid donates hydrogen ions. It contains hydrogen ions. Okay. So what is an acid? An acid is a proton donor. The next is identify an acid in the reaction shown above. So in this reaction, which one is an acid? We have said an acid is a proton donor. You can simply say from this one, these are the same species. Okay, so this is ammonia, NH3. Okay, this one is H2. We are interested with the proton. So look at hydrogen. So here we have hydrogen. You simply look at the fact that from here to here, there is an hydrogen added. An hydrogen is added here so that it forms that. In this other instance, an hydrogen is removed, if I can use those terms in a layman's language. Now, hydrogen is added here. From where? From this species. So water takes off its hydrogen. Now, when we put it in these terms, we say this donates hydrogen to this. Okay. So when we say water donates, so this species donate. Okay. always whatever donates is a donor. So we've answered the fact that an acid is a proton donor. In this question, this species here acts as an acid. Why? Because it donates a proton to NH3. So the acid in this instance is H2O. That is the acid in that reaction. Okay? For the reasons that we have given there. There is another one here. Let me just write on board. This is our board today. So, NH2 So you have that equation. Most of us like to hate chemistry. When you look at an equation like this, you wonder. You have never seen such a species, and even this one.
Kuna vile unaweza ongeza hapa, si nimeongeza ndo mwisho.
Unless Arigo is
Sawa tu, bora uongeze.
okay. Sorry for that interruption. Now, so we have this equation here. Also the same case, identify the acid in the forward reaction, and of course you explain. Now, in this equation, we only know that an acid is a proton donor. So we want to look at where hydrogen has been added there. So this is NH2. Basically, look at the H. So this is H2. When it comes here, a nitrogen has been added. In this other instance, hydrogen is removed. As we said earlier, so this one is a proton donor. This one acts as a proton acceptor. So therefore, this acts as an acid for that case. So the second substance species act as an acid. Next question. The next question says dilute nitric acid can react with a solution of sodium carbonate. Write an ionic equation for the reaction. So that's a reaction between dilute nitric acid and sodium carbonate. So dilute nitric acid is that. Sodium carbonate is written as such. For the reasons we know that sodium is valency 1, carbonate is valency 2, so when you exchange, it is Na2CO3. Okay, so we want to write an ionic equation. Now, there are several ways of writing an ionic equation. What we were taught for us to understand is these two react. Now, what we know from our Form 1 work is that when a dilute acid reacts with a carbonate, let me write here, when an acid, just a reminder, an acid reacts with a carbonate, it gives you a salt, water, and carbon 4 oxide gas. So those are the three products. When a dilute acid reacts with a carbonate, then you have a salt and water and carbon 4 oxide. Now here we have nitric 5 acid. We have sodium carbonate. So sodium carbonate reacts with nitric 5 acid to form sodium nitrate. So if I write the long equation is nitric 5 acid reacts with sodium carbonate to form sodium nitrate and water and carbon 4 oxide. My whiteboard is smaller. So sodium reacts with the sodium carbonate reacts with dilute nitric 5 acid. Of course, these ones are this is liquid, this is gas. When you balance, you have 2 and 2. Okay. So there is the long route of breaking. You break hydrogen ions, nitrate, ions, sodium, ions, carbonate, ions, sodium, ions, nitrate. This bond will not be enough for us to break. So we have water here and gas. So those are the products that we have. Now, for you to write an ionic equation, when you have an acid reacting with a carbonate, let us say, because we are talking of acid as a proton donor, then when you are talking of the acid, you are talking of the hydrogen ion. The hydrogen ion, because we have said what makes an acid to be an acid is the hydrogen ion, actually the proton. The proton makes substance to be an acid. So when you say dilute nitric 5 acid, what you are talking about is the hydrogen ion. Now sodium carbonate is a carbonate, so it is a salt. So that is a CO3 2 negative. So when you want to write an ionic equation, that is an acid reacting with a carbonate. This one is in aqueous state. This is aqueous. Then it forms these two. You have water and carbon 4 oxide gas. So that is the reaction. Check whether it is balanced. Hydrogen is 2 here, so this is 2. So you have a proton, hydrogen ions reacting with carbonate ions. This is carbonate ions to form water and carbon 4 oxide gas. So that is the equation when dilute nitric acid reacts with sodium carbonate. That's the ionic equation. Okay. Next, number 3. When 2 molar potassium hydroxide solution was added to solution R, a white precipitate T was formed, which dissolved in excess potassium hydroxide solution to form solution L. Let me come up again. When potassium hydroxide, when 2 molar potassium hydroxide solution was added to a solution R, a white T was formed, which dissolved in excess potassium hydroxide solution to form solution L. Solution R forms a white precipitate with sodium chloride solution. So let us try to draw a chart here. Now, we have solution R. Okay, the question says, when 2 molar potassium hydroxide solution is added to R, a white precipitate T was formed, which dissolved in excess to form solution L. Now, so we say dropwise. Okay, we want to change the statement into a table. So dropwise forms a white precipitate L. So this one forms white PPT L. Now in excess, the question says, which dissolve in excess potassium hydroxide. Now when you have excess, then what happens? It forms a white forms white precipitate. A white precipitate T was formed, which dissolve in excess to form solution L. To form solution L. That is it. And then sorry. This is white precipitate T. White precipitate T. Then solution R forms a white precipitate with sodium chloride. So sodium chloride, add sodium chloride there, and you have a white PPT. Okay, white precipitate solution R forms. Oh, sorry. This one is not here. So solution R, when you add sodium chloride, forms white PPT. Now, from what we know, acid bases and indicators, acid bases and salts, potassium hydroxide 2 molar potassium hydroxide is also the same as 2 molar sodium hydroxide. So we normally use sodium hydroxide and aqueous ammonia to test for the presence of cations. Now look at this. When potassium hydroxide is added to R, there is a white precipitate soluble in excess. So normally we say white PPT soluble in excess. Because it is in excess. So we have 3 ions for this case. We have, we call them ZAP. We normally call them ZAP. You can say from this up to this point that this solution R contains at least one of these ions. So R contains either zinc or aluminium or lead. Now, the additional information here is sodium chloride is added, you have a white precipitate. The salt that is formed here is chloride. From our Form 2 solubility work, we said all chlorides are soluble. All chlorides are soluble except lead, chloride, and silver. So leave alone silver because it's not part of the cations that we talk about. So all chlorides are soluble except lead. And we have said here, solution R may contain zinc, aluminium, or lead. So that means zinc is not there because zinc does not form a white, does not form an insoluble chloride. So the insoluble chloride is lead. So R contains lead 2 ions. That is understanding the scheme. Now let's go to the question. So the question says, identify the cation in solution R. Cation in solution R, that is basically we have said lead 2 ions. So you write lead 2 ions, not in words. You write the formula. So lead 2 ions. And then B, identify the white precipitate T. White precipitate T here. Now here, so now that we have said lead is present here. So lead reacts with hydroxide ion to form lead 2 hydroxide. So white precipitate T is called lead 2. So the question says name. So if it is name, you give the name, you don't write the formula. The formula you only write when you are asked to identify. So when the question says identify, you can either choose to write the name or the formula. But now the question says name precipitate T. So precipitate T is called lead 2 hydroxide. Correct. Next question is write the molecular formula of the compound in solution L. Solution L. So when it dissolves in excess, it forms a complex ion. So L contains a complex ion of lead 2. So the complex ion is the formula for the complex ion is lead. You write it like that, then you bracket 2 negative. So that's the complex ion, which we say that's why we say soluble in excess. So that is soluble in excess. That's the compound that's soluble in excess. Question 4. Question 4 says, the flow charts below show an analysis of a mixture R that contains 2 salts. Study the analysis and answer the questions that follow. So we begin with mixture R. So mixture R undergoes step 1, a certain step 1. You have 2 metallic oxides, that is water. So R undergoes step 1. You get 2 metallic oxides, you get water, you get carbon dioxide, nitrogen dioxide, and oxygen gas. Now, the conclusion we can make from that step alone, step 1, means a certain salt. Now, when we talk about this is effect of heat on salts. When salts are heated, these are the products. So we have 2 metallic oxides, we have water, we have carbon 4, we have nitrogen 4, we have oxygen. Possibly this tells you that this mixture contains a nitrate. Nitrate because of the nitrogen dioxide gas produced and the oxygen gas produced. It also contains carbonate ions. Carbonate because of the carbon dioxide produced. So mixture R contains a carbonate and a nitrate. We don't know which cations, but we have known that it is a nitrate or a carbonate. Now, leave that alone. These 2 metallic oxides add hydrochloric acid. You have a residue, you have a filtrate. Now, when you add hydrochloric acid, it means this one is a chloride. So this is an insoluble chloride. This one is a soluble chloride. From the solubility of chlorides, we have said lead 2 chloride is insoluble. That means the residue is lead 2 chloride because it is insoluble. Okay. So when you go back, that means lead 2 chloride, going back, there was lead 2 oxide here. So this lead 2 chloride. Now we don't know the filtrate. We use this to identify the filtrate. So step 3, sodium hydroxide add excess. So this is just excess. You have colorless solution. Colorless solution for sodium hydroxide, we say that is zinc, aluminium, and lead. That is ZAP. Now when we have excess ammonia means if this substance is soluble in excess ammonia, that is zinc. Now look here. When you use sodium hydroxide, we talk about zinc ions, aluminium ions, and lead 2 ions. These are soluble in excess. For aqueous ammonia, zinc is soluble. This one is not soluble. This one is not soluble. So from that equation, it means we have zinc ions in the filtrate. So the filtrate contains zinc ions. Why are we saying zinc ions? We are saying zinc because there it is soluble in excess aqueous ammonia solution. Now, so that is what we've said. Now go to the questions. So we have analyzed the chart. The first question is state the condition in step 1. We have said this is heat. The process in step 2. So this one is heat. 2 is filtration because you have a residue and a filtrate. So step 2 is called filtration process. The name is filtration. The next question here, a small portion of mixture R is added to dilute nitric 5 acid in a test tube, what would be observed? So mixture R in a test tube, a small portion you add nitric 5 acid. So what would be observed? Because we said mixture R contains a carbonate and a nitrate. Now when you add nitric 5 acid here, one is that there will be effervescence. Normally you say effervescence or bubbles if you like, or fizzing if you like. Any one of them is correct. So there will be bubbles. Why do we have bubbles? Because when an acid reacts with a carbonate, you have carbon 4 oxide gas. This carbon 4 oxide gas makes the bubbles to appear. So the observations there is because we have bubbles. The reason, the observation is there is bubbles or effervescence or fizzing. The reason is because we have production of carbon 4 oxide gas due to presence of a carbonate. Next is write an equation for the reaction between cation in X and sodium hydroxide solution. So this one, the cation is X and to form a colorless solution. So this to form this. So the equation is, we have two equations there. So zinc, we have said that is zinc. So zinc ions react with hydroxide ions, first of all to form zinc hydroxide, which is a white precipitate. So that one is a solid. Now, and then because it is white precipitate soluble in excess, then the excess is zinc hydroxide reacts with more hydroxide ions so that you have a complex. The complex is zinc. That one is 4. You enclose with a square bracket and then 2 minus. So this is the aqueous, which we have said is a colorless solution. So those are the two equations that you have. The first equation is where white precipitate. The reason we wrote this, you can as well choose to omit this and then you write that one alone. There's no problem. But it's because this one is a solid. Because we say white precipitate soluble in excess. So the hydroxide is a solid, it is a white precipitate, but it dissolves in excess to form an aqueous solution, which is a colorless solution there. Correct. Explain how water vapor in step 1 can be identified. So this water vapor. So that owes to the chemical test of water. So the question says, explain how water vapor in step 1 can be identified. That is the chemical test of water. The chemical test of water is you always use hydrated copper 2 sulfate. You use hydrated copper 2 sulfate. Whose color changes from blue to now if you are testing it with water, it changes. Hydrated copper 2 sulfate is blue. Now, without this is with water of crystallization hydrated. Without becomes anhydrous. So hydrated is blue, anhydrous is white. So the question says, explain how the water vapor in step 1 can be identified. So how do you identify the water vapor? So what you say is you take the water vapor through maybe a test tube or a boiling tube containing anhydrous copper 2 sulfate. Let me write the whole procedure here. So how to test whether it is water? So you bubble the vapor. Bubble the vapor through a test tube or a boiling tube containing anhydrous copper 2 sulfate. Now you also need to state what happens. So what happens is the color change from white to blue. So color changes from white to blue. That shows presence of water. Next, okay, because of time, I want us to do 7. So let's look at question 7. Now question 7, you have solid X. So solid X undergoes step 1 here to form a colorless gas which forms a white precipitate with lime water. Basically, when you see a white precipitate with lime water, the gas is CO2. So this gas here is carbon 4 oxide. Now, solid X also, nitric 5 acid is added. You have solution Y. So this one is a nitrate. Now, nitrate, a few drops of sodium hydroxide forms a white precipitate which is soluble in excess. So this whole procedure represents white precipitate soluble in excess. So that's for sodium hydroxide. You remember ZAP. Now for aqueous ammonia, dropwise until in excess. So dropwise white precipitate, excess colorless solution L. So here you also say white precipitate soluble in excess. So we have said for aqueous ammonia, white precipitate soluble in excess is zinc ions. This one is ZAP. So that means in this solution Y, we have zinc ions. So when we have zinc ions here, this was nitrate added, then it is zinc nitrate. So Y is zinc nitrate. Now, when you go back here, you had a colorless gas which forms a white precipitate with lime water. So it's carbon 4 oxide. That means this step 1 is heating. So for earlier we said for carbon 4 oxide gas to be formed, then a carbonate is heated. And because we have said X contains zinc ions, then this one is zinc carbonate. So why do I know carbonate? Carbonate because of the carbon 4 oxide formed. How do I know it is zinc? Zinc because of white precipitate soluble in excess aqueous ammonia. So solid X is zinc carbonate. Now go to the questions. Identify solid X, zinc carbonate. Write an ionic equation to show the formation of the white precipitate. So for both, we had written the equation. Zinc reacts with hydroxide to form zinc hydroxide. That's the equation we wrote previously. Why would the gas S, this gas S, not form a white precipitate with a solution of sodium hydroxide? Now, we have gas S is carbon 4 oxide. Lime water is calcium hydroxide. The thing is, when carbon 4 oxide reacts with calcium hydroxide, it forms calcium carbonate. Calcium carbonate in form 2, we said that all carbonates are insoluble except sodium and potassium. So this one is insoluble. Because it is insoluble, it forms a white precipitate. Now, if we have, instead of sodium hydroxide, instead of calcium hydroxide, we have sodium hydroxide. Now, because instead of calcium hydroxide, we have sodium hydroxide. So sodium hydroxide will form a sodium carbonate. And sodium carbonate is soluble. So it won't form a white precipitate as for calcium carbonate. So the reason we have said, the question says, why would gas S not form a white precipitate with a solution of sodium hydroxide? The reason is because when carbon dioxide reacts with sodium hydroxide, it forms a sodium carbonate, which is soluble salt. It is a soluble salt, so it is not a white precipitate. So that's for that question. So those are a few questions from that particular topic, acid, bases, and salts. Maybe next time we will go a bit far. So let us switch gears now to the final, just sampling a few questions. Next time we shall do a whole thing of one topic. So next is organic chemistry. So let's look at organic chemistry. A few questions there to keep us our wheels rolling. So the questions we will handle takes both organic chemistry 1 and organic chemistry 2. We are aware that organic chemistry 1 is in form 3. This one is about alkanes. Just a reminder, alkenes and alkynes. Organic chemistry 2 is in form 4. It talks about alkanols and alkanoic acids. When we were in form 3, we said alkanes are single bonds, alkenes double bond. So we have a carbon-carbon double bond, normally represented as that. Alkynes are triple, so you have a triple bond like that. Alkanols, we represent them as ROH. Alkanoic acid, I know most of our students have, maybe most of them have not done this, but just to mention, alkanoic acid is have COOH. So these are functional H and then oic and then in and iron. So this is basically what we look at here. Now let's look at that first question. We have bromine introduced. So we have one bromine this side, the other bromine this side. Most likely the reagent here is bromine gas. Now downwards, this is alkyne. This one is alkene. Now what happens here is the bond is reduced from a double bond, from a triple bond to a double bond. So the reagent for this is always hydrogen. Okay, we shall look at that practically. Now to this side we have 1 mole of hydrogen bromide, so substitutes also 1 hydrogen here, one bromine will come here. Then from alkene there is a concentrated sulfuric acid to form substance N. Okay, let us explain that here. Simple like this. Now to reduce bonds, you can reduce triple bond to double bond and even to single bond. So for you to reduce triple bond, this is the basic thing that you need to know. Reduced to double and double reduced to single bond. Assume this. Okay, so this one can be either that or direct. Now, for this to happen, you require hydrogen. The reagent you require is hydrogen. Always with a platinum catalyst and temperatures of 150 to 250. So, this process require the same. Hydrogen with platinum catalyst, 150 degrees, 250 degrees. This one requires the same. You are simply adding hydrogen. You reduce. So this 1 mole. When you add another 1 mole here, you have hydrogen is the reagent, and then platinum, and then 150 degrees to 250 degrees. Now you can also go direct from triple bond to single bond. The same thing is required, but now it will not be 1 mole. So you just will have hydrogen, you have a platinum catalyst, temperatures 150 to 250. This, by the way, is called hydrogenation. So that process is called hydrogenation. What you say is used in the manufacture of margarine and Blue Band. So that is the process we've represented there. Now, so let's go to that question. Let's go to the questions now. Name substances X and N. So substance X and N. Substance X is where you have substance X, we have triple bond, we have ethyne. This is ethyne, and then pass through 1 mole of hydrogen bromide. So 1 mole of hydrogen bromide to form substance X. Now what happens, what you need to know here is that this is hydrogen and bromine. Okay, so that's hydrogen and bromine. When it is added to alkyne, hydrogen will add to 1 carbon, bromine will add to 1 carbon. This bond breaks. So here you will have this 1 hydrogen adds there, and then the bond is now reduced from triple bond to double bond. So here you will have hydrogen and bromine. So that is substance X. Now, for us to name this, you find that we have bromine. So the when you are naming, we have a parent name and then the branch. So the parent name here, you get it from the number of carbon atoms. So you have 2 carbon atoms, but there is a double bond. So 2 is F. An organic compound that contains 2 carbon atoms is called F. Now, because it has a double bond is in. So you say that one is ethene. There is no need to say it 1 in, because the double bond is in carbon number 1. So you just call it ethene. Now we have a branch. A branch is bromine at carbon number 1. So you have, at carbon number 1, you have a bromine. So carbon number 1, you have a bromine. So in order to give it a name, then you take the whole name now becomes 1-bromo. So when it is a bromine, in naming, you call it bromo. So it is bromo. So 1 bromoethene, or simply leave this, it becomes bromoethene. So that one is called bromoethene. The next question is name reagent M. Reagent M. So from here to here, what has been added only is the bromine. So this is bromine gas, Br2. So because the question says name, when you are told to name, you name. That's why we have said X is bromoethene. Oh, we have not named N. Now look at N. This is alkene, which undergoes a certain process here to form substance N. Now, CH2 is sulfuric 6 acid is passed through that. Now this one, when sulfuric 6 acid is added to this, now sulfuric 6 acid contains hydrogen and sulfate ions. So what it forms here is a compound of this kind. So you have 2 hydrogens. This is alkene. Now 1 hydrogen will add here this, and the other hydrogen adds here. And so this one breaks, so you have hydrogen and you have hydrogen sulfate. Okay, so hydrogen sulfate. So this one forms HSO4. So this one is called ethyl sulfonate. So this one is N. So N is ethyl sulfonate, and so ethene undergoes this reaction. Addition. This is an addition reaction where sulfuric 6 acid is added, and then you have normally when an alkene and concentrated acid, sulfuric 6 acid is added to alkene, you have an alkyl sulfonate. So the alkyl in this case is ethyl because there are 2 hydrogen atoms. Then this one is a sulfonate. So it is called alkyl sulfonate. So that is this. That is N here. So this N here is called ethyl sulfonate. Next. Reagent M, we have named it bromine gas. C, ethene undergoes polymerization to form a polymer. So this ethene undergoes polymerization. In short, there could be a polymerization there. Then give an equation for the reaction and name the product. All right. Now, this is polymerization. Now, polymerization is a type of addition reaction. Polymerization is actually called self-addition. Self-addition. Self-addition is where you have an alkene. This is an alkene called ethene. It adds to another ethene. So another ethene is added here. Another ethene. And then to form, so because you have ethene and ethene, they combine to form very many ethenes. So this, you have 1, so you connect the 4, so you will have 1, 2, 3, 4. So you put a square bracket and N. Now, so this one, so that one is polymerization. So this one is called a polymer. Precisely, this is polythene. You can say polythene or polyethylene. polyethylene. Polyethylene is okay. Polyethylene is okay. So that is what polymerization entails. So that is for that particular question. So it was give the equation for the reaction and the name. So that's the equation. The name is polyethylene or polyethylene. What you need to note here is that this must cross to iandike kitu kama plus. Okay, so this it crosses that, and then n represent very many polymers to form that. Next. The next question is name 4 components of crude oil. Normally when you go to a petrol station, you will see petrol, you will see diesel, you will see gasoline, gas. There are gas cylinders there. So those are the components of crude oil. We have gasoline, we have petrol, we have diesel, we have lubricating oil, and bitumen. Gasoline, petrol, diesel, dithoro. So dithoro, you have petrol, diesel, gasoline. We also have bitumen, and which other one? We have lubricating oil. So gasoline, what is used to refill gases, normally gas cylinders. Petrol, you know the use. Diesel, you know the use. We also have bitumen, which is used in road construction, and lubricating oil for lubrication. So those are the components of oil. Next is what is the difference between thermal cracking and catalytic cracking? We have thermal cracking and we have catalytic. Now, cracking is the breakdown of long chain alkanes. Cracking is the process by which long chain alkanes are broken down into shorter chains alkanes. We have 2 types of cracking. We have 2 types of cracking. Cracking of long chain alkanes. There are 2 types. We have thermal and we have catalytic. So thermal cracking is the use of high temperatures. Temperatures are used to break down alkanes into shorter chain alkanes. Shorter chain alkanes plus an alkene plus hydrogen gas. Those are the products of cracking. When long chain alkanes are broken down or are cracked, then we have a shorter chain alkane, we have an alkene and hydrogen gas. Those are products of cracking of alkanes. We have 2 types of cracking, thermal cracking and catalytic cracking. As the names suggest, thermal is from temperature. So thermal cracking uses temperature. And then catalytic cracking uses a catalyst. So thermal cracking involves the use of high temperatures, while catalytic cracking involves the use of a catalyst. So that is the difference between thermal and catalytic cracking. The next, study the flowchart below and answer the questions that follow. Study the flowchart below and answer the questions that follow. So let us study this chart. This chart, we are starting with sugar. So sugar undergoes process W to form crude ethanol. So this one is normally for fermentation, and then to form crude oil. From crude oil to pure ethanol, this process is distillation, fractional distillation to form pure. Normally from impure substances to form pure, the process is fractional distillation. So this fermentation, which requires yeast, and then fractional distillation. Now pure ethanol, Kong sulfuric 6 acid, and 180 degrees centigrade. This process is called dehydration. Kong sulfuric 6 acid is a dehydrating agent, so this is called dehydration. It reduces ethanol, alkanol, basically alkanols to alkenes. So this substance, because this ethanol, this one will be ethene. Ethene because all OH is removed by Kong sulfuric 6 acid at 180 degrees centigrade to form substance A. So this one is ethene. So ethene reduced by hydrogen, the process we said earlier, to form substance B. We shall look at it practically. Then pure ethanol, this is called normally KIMNO4, acidified KIMNO4. Hydrogen means acidified. Now, acidified KIMNO4, this potassium manganate 7, is a we call it an oxidizing agent. So it oxidizes alkanol to alkanoic acid, and then we have sodium hydroxide to form substance C and water. Now, identify process W and Y. Process W, we have said this one is fermentation. Process Y, we don't have Y. Maybe it should be X. So X, we have said, is fractional distillation. This one process is dehydration. So this process is dehydration. This process is oxidation. This oxidation, dehydration. This one here, hydrogen, addition of hydrogen is called hydrogenation. Okay, so fermentation, fractional distillation, dehydration, and then here is hydrogenation. Going up is polymerization. So this polymerization. Now here is oxidation. This one here from alkanoic acid, and then we have hydroxide. This preparation of alkanes. So the process here is preparation of alkanes. Identify, that's okay. Name substances B and C. So substance B, where is B? Here. B, A, first of all, we have pure ethanol. Pure ethanol is C2H5OH. These ones, we have Kong sulfuric 6 acid, and then 180 degrees Celsius forms substance A. So from this, you will have ethene. You have ethene plus water. So this is ethene is substance A. And then substance A, add hydrogen there. We said hydrogen, we said platinum, we said 150 to 250. So this process is hydrogenation. Okay, so that hydrogenation gives you, breaks the double bond to single bond, reduces alkene to alkane. So that is the process. So write the equation. Okay, so substance B is alkane. This is ethane. So ethane, A is ethene. A is ethene. The next question is to write the equation for a reaction leading to A. So this is the equation. Write the equation for the reaction leading to production of substance A. So A is the equation I've written here. Alkanol undergoes dehydration to form alkene, which is that equation there. Substance B. The next question says substance B, which is this. we have said substance B is alkane, which is ethane. So substance B completely burnt in air. Write the equation for the reaction. So B is ethane. Now ethane is completely burnt in air. When all organic substances, all organic compounds, all alkanes, alkenes, alkynes, alkanols, and even alkanoic acids, all these organic compounds, when they are burnt in air, the products are always carbon 4 oxide and water. So those are the products formed. When you balance, these are two carbons. So you can write this as C2H6. So you have two carbons here. Two carbons, if you put two, oxygen will be, okay, you have six hydrogens. So you will have to put 3 there, which makes it odd number. So that means this is 4, and then 6, 12. This is 6 plus 14, 7. So that's how you write the equation. This is the equation. This is a gas, then water. So that is the equation when ethane is burnt in air, completely burnt in air, so forms carbon 4 oxide gas. The next question is, the next question is, state and explain the observation made when bromine is added to a gas jar full of substance B in the presence of light. State and explain the observation made when bromine is added to a gas jar full of substance B. So where is B in our chart? So we have B here. In sunlight. Now, B is this. B is then. Now, when bromine is added here, and we have sunlight, this particular reaction is the only reaction that alkanes can undergo. This one is called substitution reaction. So this substitution reaction, alkanes will always react with this. Bromine substitutes hydrogen. So if you have this and hydrogen is added, the question says, state and explain the observation made when bromine is added to a gas jar full of substance B in the presence of sunlight. So when you have bromine added there, and then it forms C. So this one is C. If it is 1 mole of bromine, so if it is 1 mole of bromine, 1 mole of bromine substitutes. Substitution is substitute. So 1 mole of bromine substitutes 2 hydrogen. But now if it is not 1 mole, just a lot of bromine is added, excess of it, then you have all hydrogens replaced and all the hydrogen. So you will have this, all of this one, instead of hydrogen, you will have bromine. So a lot of when a lot of bromine is added, this is what you have. So instead of hydrogen, you will have C2. Instead of H6, you will have Br6. So that is the bromine replaces or substitutes hydrogen. So that's the reaction, unless when the question says 1 mole of bromine. If it is 1 mole of bromine, then only 2 bromines replace 2 hydrogens. Very quickly. very quickly. Polymer D has a relative molecular mass of 112,000. Calculate the value of N. So polymer D. So this one has to be polymer D. We don't have any other polymer in this chart. So this polymer D has a molecular mass of 112. Calculate the value of N. Now, the polymer is polythene. So this polymer has a molecular mass of 112,000. This is ethene, so this is 1. We know that always carbon is 12 and hydrogen is 1. Rm of carbon is 12, Rm of hydrogen is 1. So when you take these are two carbons, so 12 plus 12 is 24 plus, so 12, 12, 24 plus 4 hydrogen. So each hydrogen is 1. So plus 4 gives you 28. Now for you to find the number of the N, then you say this is 28. So 28N is equal to 112,000. 28N is equal to 112,000. What is 28? 28 is the molecular mass of 1 ethene. And then N you don't know. N is the number of polymers, the number of monomers. So over 28 over 28. So this and this. N, when you use your calculator, this is 4,000. I think 4,000. The number of polymers are 4,000. I mean not polymers, the number of monomers. So you have 4,000 monomers, so N is equal to 4,000. Next. Now, I want us to use this as our last one. Now, number 3 is name the following organic compounds. Name the following organic compounds. The first one we need to name is CH3, CH2, C. Okay, so look at that organic compound. Now I told you earlier that for you to name an organic compound, you need to find the parent name. After finding the parent name, find the branch. And then you will have the whole name. Now the parent represents the longest carbon chain. So the longest continuous parent is always longest continuous carbon chain. In this case, the longest continuous carbon chain is 1. So you have 1, 2, 3, 4, 5, 6. So any organic compound with 6 carbon atoms is called X. So because it is an alkane, then you say it hexane. So this is hexane. So that is hexane. That's the parent name. The parent name is hexane. Then the branch. So you see 1, 2, 3. At carbon number 3, you have a branch. So carbon number 3, you have a branch. This one is called a methyl. So when you write CH4, this one is methane. When it is -1 carbon, CH3, then that one is methyl. So this is methane. This is methyl. So at carbon number 3, you have a methyl. And then you also have another methyl at carbon number 3. So you have another methyl. Those are 2 branches. So 2 branches of the same kind at carbon number 3. Now, when you have methyl and a methyl, normally we combine these to form di. So we call it dimethyl. So the name of the branch, first of all, is 3,3-dimethyl. So it is 3,3-dimethyl. That translates to, at carbon number 3, 2 positions, the same position twice, we have a methyl. Now, putting the whole name together, you always begin with the branch and the parent name goes to the last end. So the name becomes 3,3-dimethyl hexane. 3,3-dimethyl hexane. Now this name is, hexane is the parent name, and then you have the branch here. So that is the name of that organic compound. The next organic compound is, draw the following. So we have named the first one. The next is, draw the following. So you have two bromo, 4 chloro. You have two bromo, 4 chloro, 3,3-dimethyl hex 1N. So 2 bromo, 4 chloro, 3,3-dimethyl hex 1N. Okay. So how do you draw this? Such a long name, eh? So the parent name is always the last. So this is the parent name. And from the parent name, hex means 6 carbon atoms. So X is 6 carbon atoms. Draw the 6 carbon atoms. So you have 1, 2, 3, 4, 5, 6. So we have drawn X. Now, 1 in. This 1 in shows there a double bond at carbon number 1. Double bond at carbon number 1. So carbon number 1 here, you have a double bond. Okay? So that is the parent. So we are done with this. We have drawn the parent. Now next. So you can begin from. So you have 6 bonds and then double bond at carbon number 1. Now at carbon number 2, you have a bromine. So you say 1